I can't see one single star, can you, George, anywhere?
Being a British stargazer has never been easy.
Yes, and there is Saturn. Is it gone? Oh, no.
Just as I got it on the crosswires, it blacked right out.
How absolutely typical. There's nothing we can do about it.
It's 1:30, it's raining, and the satellite photo shows cloud for the rest of the night. So all we can do is shrug and hope for better luck tomorrow.
I love it, Chris. Always the optimist.
I do try. Over the years on The Sky at Night, we've tried to bring you the experience of stargazing.
But as you can see, with the British weather, even with the best will in the world, things can go horribly wrong. How many of us have planned a night of stargazing only for it to be ruined by the weather forecast?
So today, we're here in the gorgeous Oxford Botanic Garden with a slightly different kind of show for you. We'll be offering you alternative, equally dazzling spectacles for when the nights are short and the stars are hiding.
Welcome to the Sky at
Day. Now, there's never any guarantee with the weather, but these long summer days do provide an opportunity to discover astronomical wonders hiding in plain sight.
Absolutely. Now, the star of today's show is definitely our local star, the sun.
So as well as telling you how to observe it safely, here's what we've got coming up.
In this programme, we'll speak to the scientists who have flown space probes into the sun's atmosphere.
We couldn't power the spacecraft without the power supply melting. We couldn't design a heat shield that wouldn't burst into flames.
And we meet the amateurs gazing up at the sun from down here on Earth.
We have exploding prominences that's erupting from the sun. We see plasma shapes on the edge of the sun that look like monsters.
George Dransfield is back, hunting for micrometeorites in the sunshine.
Wow, there's a chunk of magnetic stuff there. There must be some micrometeorites in here.
And we look west to Bristol for a sunset masterclass from Dr. Hannah Wakeford.
As we move towards sunset, the sun is moving through a longer distance of atmosphere, so all we end up with is this beautiful red-orange sunset.
But first, to the star of the show. Despite being our local star and our constant companion for over 4.5 billion years, there are still many aspects of the sun that remain a mystery. Chris spoke to Justin Casper from the Parker Solar Probe, NASA's record-breaking mission that flew into the sun's atmosphere.
Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the sun.
Thank you for joining us. Where did the idea for the Parker probe come from?
Before NASA even existed in the United States, there were some studies that were carried out that asked the question, if you could send a satellite into space, what kind of science would you do? And one of the ideas was the concept of a solar probe. And so solar probe, the goal was send a spacecraft close enough into to the sun that you could dip into its atmosphere, figure out why its atmosphere was so hot, and what exactly it is that happens in the atmosphere that makes these jets that we call the solar wind appear and flow through interplanetary space.
So why did it take so long between the initial idea and the launch of the Parker Solar Probe?
We had a few technical challenges. First, it was just technically impossible. We couldn't power the spacecraft without the power supply melting. We couldn't design a heat shield that wouldn't burst into flames. And then over time, we started figuring out new tricks. So using Venus instead of going out to Jupiter to get close to the sun, using special solar panels that can survive with high temperatures, and actually pumping water behind them to cool them off so they don't melt when we're near the sun.
And of course, the whole point of doing this is to take some scientific instruments along with you. I know you're involved in it's SWEEP, isn't it? Your instrument. Tell us about that instrument and what it's trying to do.
It's a lot like recording the weather on Earth, You want to know how windy it is, which way the wind's going, what the pressure is and how it's changing. And so the sweep investigation measures the main particles in the sun's atmosphere. And we scoop up samples of the sun's atmosphere each time we fly by. And then the sensors on the spacecraft analyze those samples and they report back, okay, here's the temperature, the direction, there was this much helium, the electrons were headed this way, the helium was headed that way.
And while you're now there, you've had a few orbits close to the sun. What have we found out so far?
We flew through that outer boundary. We call that the Alphane surface for the first time last year. That was very exciting. But one of the surprises was the surface, while it was very clear when we were above or below it, it had to be very wrinkled to explain how we were able to move in and out. So different kinds of solar wind coming from different regions on the sun seem to push the sun's atmosphere closer or further. So this, big surprise, it's not just a simple spherical shell, it's some very complicated surface.
And what did your particle experiment record as you were going in and out of that surface? Did you see a change?
What we weren't expecting that was amazing to see is the pressure exerted by the particles in the sun's atmosphere in that region. So the pressure of the ions, the pressure of the electrons, that pressure was 100 times smaller than the pressure exerted by the sun's magnetic field. Those particles were really trapped and forced to move wherever the magnetic field decided it wanted to move. And the magnetic field was calling all the shots. And it was a real surprise to see that, even though we were still, millions of kilometers away from the sun.
What are you most looking forward to in what's left of the Prime mission? What are the results that really excite you?
So what's going to happen now over the next couple of years is we're going to get, nearly twice as close. And I really think we're going to be able to make that connection finally between the surface of the sun is doing something, and that's resulting in this super hot atmosphere and accelerating the wind in these in given ways. And I think we're going to unlock those secrets.
Excellent. It's really exciting stuff and a great mission. Thank you so much for telling us about it, and we'll catch up soon.
My pleasure. Great talking to you.
Unlike the stars in the night sky, we can see our star all year round. And moreover, we can observe its atmosphere and its surface. We don't even need the Parker Solar Probe to do this. We went to Bath to meet Simon Holbeach and discover how he's showing his community the sun in a whole new light.
Looking directly at the sun is extremely dangerous and can permanently damage your eyes. But there are ways to safely observe the sun using specialist filters. Simon uses these at his solar observation events.
I was about 9 or 10 when I got my first telescope and managed to take it outside and start trying to find things in the night sky. I endured hours of frustration trying to find any objects in the night sky. I even thought the moon was going to be really easy. Turned out it was really tough as well. But the biggest leap was actually joining a local astronomical society. For me, discovering outreach was a real important part of my life. I learnt that I could actually help out other people directly, to inspire other people, to get them to look at the world in a different way.
Are the two dots next to each other?
Yeah.
They're close,
Yeah.
yeah. Do you see it?
And so it's absolutely delightful today when we can come out in the sunshine and use the sun as our reason for being outside. It's an astronomical object, and we can look up and wonder about the science behind it. So fingers crossed the sun will eventually find a way through. So today we've been using several different methods to look at the sun. We've been using a pair of binoculars, and the light goes through one side of the binoculars, and we project it onto a piece of card. Okay, that is a sunspot. So the sun has different layers. The base layer that we can see is called the photosphere, but there's an atmosphere above it called the chromosphere. So what we've got is some specialist telescopes to be able to see those two individual layers. We've put a filter on the front which takes out most of that really harmful sunlight. So 99.999% of the light with some of our filters. And that allows us to put an ordinary eyepiece behind the telescope and actually stare down the photosphere of the sun. We can see, instead of one big splodge that you might see with the binoculars, we can see the individual sunspots. It's a great time to look at the sun at the moment. We're just coming out of a solar minimum and we're building up towards solar maximum. So come the next couple of years, by 2024, 2025, the sun should look like myself when I was a spotty teenager, absolutely covered in sunspots, and we'll be able to see it all changing very dynamically. But what really interests me is that there's an atmosphere above the sun, the chromosphere. And that gets really excited by all the energy that's coming through all these sunspots, and it's in constant turmoil. So using the red light telescope, we're actually able to look at the solar prominences. All the stuff that's coming out of the sunspots is arcing through, making beautiful fountains on the edge of the sun, contrasting with the darkness of space. So you get some people that will just look through and go, oh, okay, well, that's interesting.
So, do you want to have another look?
So occasionally you'll get someone who's absolutely inspired, where they'll just look through and they just can't stop looking. They want to have another look. And we've got a queue of people behind them. So it's one of those moments in life where you've got to say, I really want to encourage you, but let's move you to the next telescope. Or just hang around 15 more minutes and I'll give you another look. I know it's been a successful observing event because people have talked at the eyepiece. So it goes slower, so it's spinning faster. And that kind of... But more importantly, it's when they're walking away with their parents or together and just having a general chit-chat about what they've seen and how exciting it's been. And I know that that conversation is going to continue in the car, back at home, and potentially in the school or in the workplace. And people are actually going to be looking up and enjoying the sky much more than they were the day before.
There are many champions of astronomy up and down the country. But if you want to get involved, get in contact with your local astronomical society. Now, I'm sure you remember George Dransfield, the astrophysicist who went on an adventure to Antarctica. Well, she's back, and this time she's on a mission for the sky at night.
Besides awesome stargazing conditions, there's another thing Antarctica was perfect for. Oh my goodness, look at that waddle! No, not penguins, meteorites.
Now sadly, I never got to search the snow for little space rocks. But whilst hunting for daytime activities to engage my students with astronomy, I heard that I could find micrometeorites right here in Birmingham.
And apparently the best place to find them is on a roof.
As meteors tear through the Earth's atmosphere, tiny particles break off, raining down from the sky onto mountains, forests, and even urban rooftops. Tons of this cosmic dust sprinkle the Earth every day, meaning these tiny micrometeorites are more common than you might think.
So I'm hoping to find some micrometeorites in all this dust I'm sweeping up, but it would take me ages to find them manually. Fortunately, micrometeorites, like their meteor parents, have a really high iron and nickel content, so I can find them with the help of my magnet. So much dust! There must be some micrometeorites in here. Wow, there's a chunk of magnetic stuff there. Not all of this is going to be micrometeorites, but what I'm going to do now that I found the magnetic stuff is give it a bit of a wash and see what's in there.
Micrometeorites, also known as cosmic spherules or even stardust, aren't a recent discovery. But the fact that anyone can find them anywhere is a new idea pioneered by Norwegian geologists Jon Larsen and Jan Braley Kiel.
Okay, I've been at this for a while now, and I think I might have actually found one, but I'm not entirely sure. So I'm going to get in touch with the guys who pioneered this method and see what they say about it. Okay, so thank you guys so much for dialing in and helping out. So I've been trying to search for micrometeorites all day, and turns out it's not as easy as I thought. So how did you guys first figure that you could search for micrometeorites in an urban environment?
13 years ago, in the summer of 2009, I was having breakfast outdoors on the white table on my veranda, and I suddenly noticed that there was something strange, because there was a shiny dot. So I picked it up on my finger and I thought, wow, this is a rock. It triggered my curiosity big time. And from then on, it was no return.
And you guys haven't just been like finding them, but you've come up with a really cool special technique for photographing them. And I've seen some like otherworldly pictures you've taken. So how did you design that photographing technique?
So this is the setup.
Oh wow!
As it is, so it's the footprint is very, very small. It's extremely compact. Each of the images that you have seen on the net consists of between 200 and 1,000 single images.
Wow!
In some cases, up to 1,200, 1,300 images. At this very high magnification, the focus depth is extremely shallow.
And what we are doing is we are staging the space rocks like any portrait photographer would do, with putting light and play with light and shadow in order to make the best result.
Wow. So what are the main categories then? What are the main groups that they kind of fall into?
Depending upon the entry angle, etc., that creates the entire variety of types, from the unmelted ones until the completely melted ones. And in between, there are, let's say, a handful of main types. Like when they start to crystallize, it's curves, olivine crystals, and they get smaller and smaller, and up to very fine-grained crystal lumens.
All these micrometeorites, they are not two are alike.
You recently met the person who went all the way to Antarctica to find these micrometeorites, and then so how did the story go?
At that time, the consensus in academia was that the cosmic dust particles, of course, you cannot find them. Yeah. So Michel Moret, he thought, well, in the cold desert at the South Pole, it's below zero all time. If a particle lands there, it might be frozen. So it might be an archive of frozen micrometeorites within the blue ice of Antarctica. And he went there, and then he found them. Last month, I visited the old master, and we paid a tribute to him, thanked him for his pioneer work. And just for fun, I took some magnetic samples outside his house, and in that dust, there was one micrometeorite.
No, really?
Yeah.
Yes.
Oh, wow.
So the guy who went to the end of the world to find the micrometeorites, he actually had it just outside his own house.
That is really, really fascinating, and I absolutely love that story. So this is what I found today on the roof of the University of Birmingham. So what do you think? Am I onto something?
Okay, so size-wise it should be okay, and the color is okay, but the black material on the top is something that we do not regularly observe.
So, but I think that the lack, if you have been on the roof and found only one, it tells me that you have looked in not the right places in the right way, because any roof anywhere, even in remote places, will be so filled with spherules.
Okay, brilliant. So I didn't find one this time, but now I am equipped with better information and I'm motivated to go out there and try again. Well, thank you again so much for your time, both of you. It's been an absolute pleasure to meet you.
Thank you, likewise.
If you want to get involved in that meteoritic daytime activity or the Project Stardust Citizen Science Programme, then head on over to our website where we've put a guide on how to get started. Now, with his favourite daytime observations, is Pete, a man who's finally got a good night's sleep.
Now, it probably comes as no surprise that the sky at day can be just as cloudy as the sky at night. But what might be a surprise are the number of things of an astronomical nature that you can see during the day. The sun is an obvious candidate, of course. The moon can be seen often during the day. The problem with the moon, when the sun is up, is that it doesn't stand out quite as well as it does at night. So you have to know roughly where it is, and you have to look that little bit harder. As well as the moon, there are the bright planets, of course. Venus can often be seen when it's far enough from the sun in a clear blue sky, again, so long as you know where to look. Mercury can be seen with a telescope, and so can Jupiter and Saturn. But as well as the daytime objects you can see, there are other interesting phenomena which are linked to the end of the day. And one in particular really stands out for me. When I was a boy, I read about what's called the green flash. This is an effect which occurs when the sun is really low down in the sky, close to the horizon. Typically seen over a seaward horizon, the top of the sun is supposed to go a vibrant green. Well, it turns out that the atmosphere acts like a giant prism, and bright objects, when they get low down, have their light split or spread into a spectrum of colour. Now, the top of the bright object will have the blue-green part of the spectrum, whereas the bottom edge will show the redder part of the spectrum. So it's like all the colours have been spread out with blue-green at the top and the red part at the bottom. Now, our atmosphere is really good at scattering blue light, so the blue component gets lost, which leaves a green fringe at the top and a red fringe at the bottom. Now, if you've got a bright object like the sun, or even the moon actually, as it's getting very low down, if the atmospheric conditions are correct very low down, the atmosphere can act like a lens, a cylindrical lens, which splits off that what's called the green rim at the top of the sun or the moon. And it will create a gap between that bit of green and the object which is set. So that bit of green hangs above the horizon, and that is what is known as the green flash.
I've been lucky enough to see the green flash a few times in my life. One of the most spectacular instances was from Chile, where the otherworldly green colour was even more vivid to the eye than I was able to capture with my camera. It was a truly beautiful experience.
Astronomers used to say that if you see a green flash, you're set up for fine weather the next day. Or someone's coming back from the dead, if you believe in pirate ghost stories. But what causes these spectacular sunsets? And can we learn to read them like the sailors did to predict a fine night's stargazing? Well, here's Dr. Hannah Wakeford from the University of Bristol with a masterclass on sunsets.
The Earth is one of a kind. Unlike if we were standing on the Moon or Mercury where you'd see the blackness of space, here we have blue skies. That's caused by particles of gas in the atmosphere scattering the white light from our star. But as we head towards sunset, that turns into a reddy orange color. The sun hasn't changed, our atmosphere hasn't changed. So what's happening? Let's go have a look. So this tank is going to act as our atmosphere. We've got water here with a little bit of milk powder in it. This torch is going to act like our sun. When the sun is directly overhead, that light is being scattered in just the short wavelengths, the blue. So that is why we see the sky being blue. As we move towards sunset, the sun is moving through a longer distance of atmosphere. It has to go a longer way. So all of that blue light and some of the other light is scattered away. So all we end up with is this beautiful red-orange sunset. You can see that here where we start out blue right at the front, and then it slowly turns orange as it goes through the water, and we see our orange-red sunset. Now, that's the physics of how we get a sunset. But sunsets can actually be a good indicator of the weather to come. So if you find yourself out stargazing without the wonders of modern technology, you can use the old adage, red sky at night, shepherd's delight, red sky in morning, shepherd's warning, to help you out. This is actually a fairly good indicator, especially for somewhere like the UK. And that's because between the latitudes of 30 and 60 degrees, we have westerly winds. If you have a red sky at night, shepherd's delight, there'll be some good stargazing for you. And that's because you've got a high pressure system on the west. And that means that you've got good weather incoming. However, if you see a red sky in the morning, that really is a shepherd's warning. That beautiful weather system has passed you already. It is in the east, so it's already blown over the UK. And that means you've got a low pressure system coming in. So the air's going to be rising, condensing into clouds, and you're going to get stormy, blustery weather like we've got today. So, red sky at night, shepherd's delight, great stargazing. Red sky in morning, shepherd's warning, get your brollies out. Sunsets aren't just a predictor of weather. They can give you examples of things happening half a world away. A volcanic explosion will jettison particles into the atmosphere, causing the sunsets to become purple. If you're in the Arctic or Antarctic with beautiful clear skies, you can sometimes see a sunset for days. But sunsets aren't unique to the Earth. We can also look at the sunsets from other planets. Mars, for example, has a blue sunset. We can go even further and look at the sunsets of exoplanets, planets that orbit other stars. And from this, we can learn more about their environments, more about what makes up their atmospheres. We've seen sunsets from bright greens to film noir grayscales, and these indicate different things in the atmosphere blocking and scattering that light. And from that, we can learn more about these distant alien worlds. Just imagine the possibilities. You will never see a sunset the same way again.
I love a good sunset.
Me too. In fact, I'm going to go back to using sunsets instead of apps to predict the weather.
Really? I think I'm going to stick with the app.
Oh, possibly wise. Possibly.
That's it for this month's programme. And I do hope we're giving you some ideas of things you can do when the clouds ruin your night stargazing.
Next month, we'll be turning our attention back to the night sky with the news that you've been waiting for since Christmas. The first images from JWST, our newest space telescope.
We'll be following the story of JWST so far and meeting some of the scientists that can't wait to get their hands on the telescope.
We hope you'll join us. Until then, from Oxford's Botanic Garden, good afternoon.